When an airplane begins to move faster than the speed of sound, it creates a shock wave that produces a sonic boom. Researchers from Massachusetts Institute of Technology have now discovered a similar process in a sheet of graphene, creating an intense beam of light which they describe as an optical boom. This form of intense light production could be used to power microchips in the next 2 years, and it promises to make them up to 1 million times faster. The researchers found that when light strikes a sheet of graphene, a two-dimensional form of carbon, it can be slowed right down. Coincidentally, the reduced speed of photons, particles of light, moving through the sheet of graphene happened to be very close to the speed of electrons as they moved through the same material. These two speeds were similar enough that significant interactions might occur between the two kinds of particles. That combination of properties, slowing down light and allowing electrons to move very fast, is one of the unusual properties of graphene. However, instead of trapping light, the researchers think these findings could be used to produce the opposite effect, to produce light. Marin Soljazic, one of the scientists involved, said, "This conversion is made possible because the electronic speed can approach the light speed in graphene, breaking the light barrier. In the case of graphene, this leads to the emission of a shock wave of light, trapped in 2 dimensions. This phenomenon is called the Cherenkov effect, which was first described 80 years ago by Soviet physicist Pavel Cherenkov. Until now, the effect had not been considered relevant to technology on Earth, because it only works when objects are moving close to the speed of light. However, the slowing of light inside a graphene sheet provided the opportunity to harness this effect in a practical form, the researchers say. In terms of practical uses, the researchers suggest that this way of generating light could be used in microchip technology. Using light instead of flowing electrons to move and store data could push operating speeds up to vastly higher levels than those achieved by today's chips. Ido Keminer, who led the study, said, "Computer chips have already reduced the scale of electronics to the points that the technology is bumping into some fundamental physical limits, so you need to go into a different regime of electromagnetism." However, one problem faced by researchers trying to develop optically based chips is that while electricity can be easily confined within wires, light tends to spread out. But, if the light could be contained within a piece of graphene under the right conditions, the beams are very well confined. So far, the work is theoretical, so the next step will be to create working versions of the system to prove the concept. However, the team hope that microchips powered by light will be available within 1 to 2 years.